Okay, something we need to talk about. Wow.
Did you make this?
No, I totally stole this off the internet. I don't even know who I stole it from. I just said Google function pointers PowerPoint, and then I picked the first one, and it looked good. So we're going to be doing that. Pointers to functions. I don't know if your book covers this too well, but if you noticed in the lab I just talked about, you are passing a pointer to a function, so we need to at least go over what that is and how you write them or deal with them. One of the most powerful features of C is that you can point to anything. So being able to point to a function, you could then select you can change what function's being called by changing the pointer. You can also store an array of function pointers if you want to try and iterate through a selection of functions. Ooh, what does that sound like? From Java. An array of function pointers, so that when something happens, you can go and call each function.
Sounds like an event type.
An event listener routine, yeah, the observer pattern. That's how it's actually implemented. And the underlying JVM, they just wrapped it inside of what they called listeners, so it was a little easier to deal with, but really it just boils down to pointers to functions anyways. Wow, this is gonna, okay, good. Whew, I thought they were gonna do it again. So they are originally introduced in C, but you can also use them a lot in C++. Sometimes they're cumbersome. Yeah, syntax baffles a lot of programmers. These are still used a lot, especially inside of kernel and system level programming. So they're a useful skill to learn. Although if you don't become a systems programmer, you probably will not encounter them again. Okay. Obviously, I told you C can point to anything, so it doesn't, not just data, it can actually point to functions. And this is a special case because instead of actually pointing to a piece of data, you are still pointing to data, but you're really pointing to a sequence of instructions to execute. Yeah, and your code also is stored in data, so therefore you can point to it. That's what this comes down to. Why do we need it? One very common way is what I showed you in last lab. I can pass you a function as a parameter call and require you to call it in every piece of data. All right, how does this look like? A function pointer is a variable. Remember, you declared your pointer beforehand, int, space, star, integer pointer. It's going to be the same thing, except for you have to give it a full function address. So in this case, this example, it is a function pointer that points to a function. So it's pointing to a function that returns an integer and takes an integer, a character, and another integer as parameters. And the function pointer's variable name is called func pointer in this situation. So the syntax is going to be a little weird at first. So up here we have func pointer is a pointer to a function, similar to how we might have had integer pointer be a pointer to an integer. You have to put parentheses around this because of the way precedence is done inside of a C. So you must make sure that it's associated with the variable. All right, you'd use the operator. Let's see if we get some good examples here. Here we go. So you might declare a pointer called a function pointer. Declare your actual function. First example, pass the 2. And C++, I highly recommend using the second one because that makes a little more sense what you're doing. You're taking the address of the function called first example and storing it inside a func pointer. But C will allow you to do the first one as well, even though it's really doing the second one. And that's just a shorthand for you. Naturally, you can use double equals, but that's comparing the memory address of the two. And let's stop there and start looking at code. All right. So we're going to function pointers. We're just going to create a simple main for this one. We'll go ahead create our standard program signature. All right. So if we looked at the slides, oh, cool. Here, it's a function pointer. First, you declare what it returns. Then you want to declare it's a pointer by putting the star, and then you want to give it a name. I'll just say operation. And we'll say it's being passed an integer and another integer, and it returns an integer. Okay. This actually declares a global variable called operation that is a function pointer pointing to a function that returns an integer and takes 2 integers. Just to give you how the syntax is a little different, I can make an int pointer, and that's how you declare it underneath. So let's create, we might have add int a comma b, int b, return a plus b, and we might also have mult as well, which would actually return the product of the 2. Alright, so we could actually set operation equal to add, or the address of add. And now operation will actually store the address of add, and just to make sure that you see what's going on, we'll go cout operation equals operation. And we'll go ahead and do this as well at add.
It doesn't need to be passed 2 ints.
The operation variable is just pointing to the function. You haven't called it yet.
Okay,
So you're just storing where the function is.
Okay.
So you haven't called it yet. You're just storing, hey, look, this is my function. Let's go ahead and make a new terminal and make sure that your professor typed that all correctly. Oh, look, he did the first time. Great. Operation equals 1 and add is at 1. That's interesting. Okay. Oh. Wonder what multiply is. Yeah, that's not right. That ain't right. Huh. Is it not like the addressing characteristic? That's weird. I wonder if cout is doing something strange. Give me 1 second. %LD. This is using the C printing out, which I've always had better luck with actually telling me what's going on, which, okay, that makes way more sense. So cout is betraying us. So I'm going to have to go with the print out function, the printf function. This is just a different way of printing things out. It's the C standard way of doing it. So I'll do, let's see, add, and add.
Are we gonna probably have to do that then too?
If you need to print it out, you'll probably have to do it, but luckily you'll hopefully never have to. And in fact, I want to use an X in these situations, so it makes it in hexadecimal. There we go. Let me go ahead and make it a little obvious that it's hexadecimal, because usually with hex you want to put 0x in front of it to signify that it's hex. Now let's run it. Alright, now that makes way more sense. Notice operation and add have the same memory location, but multiply is a little further down the memory stack. Okay.
Can you explain why it was printing out 1 before with cout?
No. I don't know why cout did that. Obviously that is not correct. My guess is that it can coerce the function pointer into a boolean, and then it became 1, which is a problem with object-oriented programming because you can't explicitly make it do sometimes what you want it to. I probably could have casted it as a log, and that may have fixed it. We can go ahead and try that real quick just for the fun of it. Okay, So if you cast it as a log, it would have then converted it correctly. So it was just evaluating it as a Boolean. So it'd either be 1 or 0, and that's why. Obviously, or not obviously, when you do Boolean, convert to a Boolean, 0 is 0, everything else is 1. So I'm going to stick with the printf here, because it's what I'm used to, but you won't have to be doing printf, hopefully, for your code. All right. Now, if you want to call it, hopefully we can go back to cout, and it will not give me a problem. So you want to do, what is it? And I do forget the syntax here. Yeah, usually it's the second one. Good. You want to dereference the function pointer, operation, and then go ahead and pass it its parameters. Maybe we'll do 10 and 24. I put an equal sign in here. Operation 10, 24. So dereference operation, which currently add 10 and 24 equals 34 because it called the add function. Oops. Naturally, if I changed it to multiply instead, notice that operations memory address is now the same with multiply. It called multiply instead, which of course returned the product. All right. Everyone good so far? All right. Might seem like a very strange way of going about it, but a nice thing here is if you have another function, and I'm going to do, let's see, void call operation being passed the function pointer, which would be an int operate. I'll just put op int comma int. And you just want to call it, you can just do, or I should say, I'll call it print operation. There we go. That'll make more sense. We'll go and copy paste this since I've already typed it out. Except for now, instead of calling it operation, I just called it op instead. Now, I can do print operation passing in add. The address of add. See if I did that right? Yep, there we go. So I can do add, and then I could also on the next one do mult. Okay. It doesn't know what function it actually is, but you passed it in as a parameter and it just calls whichever code you want. Hopefully you can see that the function being passed in can be very complicated, of course, depending on what you want to do. Okay, so similarly, what I'm talking about is in your lab, I'm going to pass you a function and you just need to run that function on every item inside of the binary tree. So you're going to want to do at least some sort of traversal. I think I told you need to do in order traversal. Make sure it is in order, and just call that function on every member data, piece of member data. Take your, yeah?
In order means from least to greatest?
Yes. So you go down the left tree until you can't anymore. Do whatever the operation is on the node, then go down the right tree. And you recurse, I should say.
So it could be removed, and then we would remove every node.
Yeah, it could, but I'm not going to pass you remove. It would be more like I'll pass you a summation formula, or I'll pass a primality test to figure out how many primes are in your binary tree. Might be another good one. Maybe I want to know the product of all the numbers in the binary tree. So there's different things I do. Or I could be doing an average where you call this function on all of them, and then at the end I compute the average. So there's a lot of different things I could do for the binary tree. All right.
I have a quick question.
Yes.
So to call a function, we needed to pass it 2 ints, and that was because...
The function parameter,
Right.
the pointer, was 2 ints.
So how will we know what to pass it? Will you tell us what parameters it needs?
So that is, yes, and I do. Let's go into lab 1.5. Notice in here, in order to traversal void visit item. So I'm passing you a function, does not return anything, and takes one element, aka the item of the binary tree.
Okay.
Great question. Anything else?
Well, it's not really related to code too much, but you said you wouldn't ever really use function pointers unless we're systems programmers.
In general, unless you're a systems programmer, yeah.
It's just because it's got to do more with that.
Let's see the best way to answer this.
Because I mean, I understand you have the capability to call a function that way, but where's the advantage exactly? It's just the ability to.
So,
pass and whatever,
what is,
basically.
I know what you're asking. Let me see if I can give you a good answer. If I can give you a clear, concise answer. Most programmers that are not system programmers, we'll say they're higher level programmers. You know, they're existing more in like the Java realm, the OOP realm up there, and so they want to package their code in the ways they're used to coding, and that is not with function pointers. That's with objects, maybe using a listener or an observer pattern or some other pattern that they're used to doing. So it's more the fact that those coders tend to use patterns, observer pattern, and then have the programming language take care of the pointers for them. Most of those programmers don't deal with pointers because pointers can trip them up a lot, which is fine. A systems programmer cannot get around pointers. They exist. You just live with them. And since the pointer exists, you know, if you want to do something like the observer pattern, you might as well just use function pointers because that's what you've been using the whole time. Hopefully that made some sense.
Yeah, it makes sense because like C++ doesn't really have the same objects listeners as Java. You know,
Java
has it very nicely set up for you.
Java has a very mature standard library.
Yeah.
C++ has plenty of mature libraries, but they're not standard to the language. So you're using Java, you are using this library. And C++ has, use whatever you want. So you could add something that does this, the observer pattern in C++, and people do, but you're not forced into it, so to speak. Great question. Any others? These are good. I like these. All right. All right, lastly, we're not going to do this for a lab, but I do want to at least talk about it because I think it's important that you understand what's going on. If you have a pointer to one function, why not have a pointer to many functions, right? Logical next step, right? An array of functions. So it treats pointer functions just like a pointer to data, so you can have an array of function pointers. Why not? So you could select a function based on an index, or you could just iterate through an array of functions. So for example, this is a function pointer up top. Actually, it's an array of file commands that each take nothing for now. Okay. So if the user selects command 0 through 6, we get subscripted by file command array and this function call. Wow. All right. You gonna give us any more code? Nope. All right, then let's not do that. Let's see if we can at least come up with a way. Let's do print operations. Now it's a double pointer. Whoa. And we'll pass it in size. Okay. What's going on here? Well, so we want to just call all the operations. So let's set up a good old for loop. And then we'll go down here. Sub I. Sub I. Okay. So I'm really just going through and calling each of the functions that's being pointed to by this, I guess, double function pointer. Let me make sure that compiles, because sometimes I don't type it incorrectly. I gave no issues. Perfect. Well, we need to create that function pointer. So, oh boy. Let's go ahead and just copy this. All right. So we're going to call it operations of size 2. And then we'll have operations sub 0 equals the ampersand of add. And of 1 equal the ampersand, of mult. And then we'll go ahead and call print operations, passing in operations and 2 because we only have 2 function calls. Okay, let's see if, nope, not quite. What was that?
You gotta do 1 instead of 2. Right?
Operate, I didn't put an S right here. That was my main problem right there. But there's 2 elements in here, so the size is 2.
I was thinking,
All right, but still not, I was not declared in this scope. I'm on line 28. Operations. Uh-oh, I may have failed y'all. All right, how was this done again? Void. Oh, they did. They did statically. Interesting. Okay, we'll try that. And I always forget if I need to put a comma after the last one, and you do not. All right. Still don't like it. Operations was not declared in the scope, but I'm declaring it right here. Oh, I forgot to put int in front of it. Okay, there we go. Sub I probably should go and put bless you, bless you. Sub 1 adds them, or sub 0 adds them, sub 1 does the multiplication. Okay. Obviously, we could dynamically allocate all the function pointers on the heap and store a lot of different pointers. And of course, you could have a 2D array of function pointers, so you could select which set of function pointers you wish to call in certain operations, etc., etc. But we're just going to stick with passing 1 function pointer. I hope y'all are all okay with that. You got that? You're good? You good with that, Matt? Yeah, okay.
Oh, man.
Oh, I mean, we could change it if you want.
Yeah, it's just passing the array of function pointers.
2D array. Or that way I can select which set of functions I want you to call.
Yes.
Good. In computer architecture, you're going to learn the what's really going on here when this happens. But that's for me. All right. Any questions about function pointers? This can be really complicated. Hopefully I've made it simple or easy to understand. The big jump here is all of a sudden thinking as a function as really just another data variable, because in C, that's all it is. All right, we're good? All right. So that'll be everything for your lab.